Hey, let's make a parabola. I'm Alvaro from C10, and today I'm going to teach you how to make one of these things. Very cool. So, let's just get into it. So, what will we need to construct one of these? First of all, you would need the quadratic equation, or I guess an example of a quadratic equation like I have prepared in this presentation. Then you would need a maximum/minimum point. Here are the xp and yp, which is like the coordinates for them. Then you would need factors of x, which is, from the quadratic, and this gives us the values of x, and this will also give us later on in the parabola, in the graph, the x-interceptions. And then we would need a graphing calculator to show all of this in a bit more detail. Here I'm going to be using Desmos. Right. First of all, you would need a quadratic equation. Here, this is mine. And here I've put a as 0.5, I've put b as 3, and I put c as 4. X stays the same. Then we would need a maximum/minimum point. Here, since 0.5 is positive, this would be a minimum point. If it was negative, then there would be a maximum point. But in this case, it's minimum. And so the graph would look something like this. This is a parabola that is going upwards to positive infinity, and it has a minimum point, which means there is a lowest possible value it can be. To find that minimum point, we would need two equations, the xp and yp, as I told you before. Here there is xp, which this formula gives us the x coordinates, which is the horizontal side of things. As for the yp here, it gives us the height, the amount of vertical upper or lower this point will be at. Here. Here, let's just try to find xp first. So this would be negative b over 2a. B here I've highlighted it as here, 3. And 2a would just be 0.5a times 2, which is 1. So xp is equal to negative 3. Box. Okay, let's save this first. Now yp, right? What's this? F, function, right? It says function of xp. This is referring to the xp that we just solved right here. So this would be function of negative 3. But what is function? Function basically just tells us to plug in whatever number xp is, or in this case it's xp, but whatever number here is into this equation here as x. So in this case, hold on, here, we substitute x for negative 3, as so. Here we have 0.5 times negative 3, and then to the second power, plus, this, right? And you can see here all of the x's are being substituted for negative 3. Simplify, we get this. Okay, this is positive because negative 3 times negative 3, negative 3 squared is 9. It's positive. Negative times negative is positive. And then half it. So 9 divided by 2 is 4.5. Then we have 3 times negative 3, which is just, negative 9. And then 4 stays. And we can simplify it so that yp is equal to negative 0.5. Let's solidify this and put this in a box again. Right. Now we have two of the three main things other than the calculator. The last thing we'd need right now is, of course, the x values, or the x factors. This is basically just an equation, or two actually, that gives us, a definite value of x, like an upper and lower bound. Here, we have this equation, and the way I'm going to be finding these values, the x factors, is through a method I really love using, which is called the cross method. This cross method tells us to put the ax squared here, the bx here, and the c here, right? This is because between these three, the one that's most common, or like, I guess, yeah, something you can get by like having these two, is, I guess, the 3 in the middle here, or sorry, the 3x, because it's not squared, so it's not that hard to get, and it's not a whole just integer. It has a value here that is undefinite yet. And the way we do this now, the way we solve this now, is we find two numbers that when multiplied gives us this. In my case, I have used x and 0.5x because, you know, x squared here, I just moved it up here. And for 4, I just used 2 and 2 because 2 times 2 is 4. Then I this is why it's called the cross method. You multiply them in a cross, so like this goes here, this goes here. This would be 0.5x times 2, which would just give us x, because, you know, half times 2 is just 1. And then x times 2, which is 2x. And here, there's the plus symbol. It's been there all the time. And this means that these values, when added, should give us this number. And 1 plus 2 does equal to 3. So this is a concrete solution. Wait, but you're probably asking, this doesn't look anything like the example here in blue. Well, now what you need to do is here and here. So you have x plus 2 and 0.5x plus 2. Let's get rid of the clutter. And wow, this looks a lot more familiar. Boom. Right. So here we have the formulas, both of them. But you're not really seeing how this could be x, right? Well, actually, for every single equation that looks like, or not really, like kind of looks like this, we assume that like this equals to 0. And so, since this is multiplication, as you can see in the brackets, there's no like addition or subtraction. This is definitely multiplication. Then either this value, or both of them have to be equal to x. And now this seems pretty easy. So here we have, let's say this one, x plus 2 should be equal to 0. What plus 2 is equal to 0? Of course, negative 2. But for this one's a bit trickier, since this is half of x. Since it's half of x, we need to find a number that is 2 times what it would take to turn 2 into 0. Since we already have that negative 2, we just need to do it 2 times. So negative 4. Since it'll go into the 0.5, this would become negative 2, and then negative 2 plus 2 is 0. So now we have our x's. We have x equals negative 2 and x equals negative 4. Put a box around it, and here we have all of our, I guess, equations. The last thing we need is to plot it all into a graph, which is where this handy-dandy app comes in, Desmos, the graphing calculator. Here I'm just going to take this and this original equation and put it into Desmos here, as so. Hold on 1 second. Let's just copy this and then paste it here. And here we have a perfect parabola that goes upwards into positive infinity. Right. And you can see here that the minimum point here, since it's going to positive infinity, there should be a minimum point, the lowest it can possibly be to still go to positive infinity. This minimum point, by our terms, should be, the x-coordinate should be -3, so the number in the front should be -3, because x comma y, it should be -3, and then the y should be -half, or -0.5, so it should be -3, -0.5. Which is here, and this is exactly what we calculated here. So it's -3 and -0.5. A bit of a bonus, here we have the x's, like the x values. These are actually also very useful because they tell us where the x-intercepts will be, which will be on -4 and 0, because you know it's on the intercept, so like the y should be like perfectly 0 as such, like because 0 here, and it's like just the x line here, right? So it's 0.4 and 0.2 right here. Oh, sorry, negative 0.4 and negative 0.2, which is, oh, yeah, sorry, I meant negative 2 and negative 4. Here. There. Okay. And as a bonus, actually, here, a really fun fact. This 4 over here has kind of been a bit of an outlier. These other equations have been used a lot, but this one has just been, I guess, used in like this one, but like, Well, this 4 actually also has a use. This use being, it is the y-intercept. It intercepts, this parabola specifically intercepts y at a rate of 4, and it's exactly once, which is here. How exciting. Thanks a ton, dear viewer, for staying, and graphs are cool, for real. Thank you very much. It's been a nice video. My name, again, is Alvaro, and I will see you in the next one. Thank you.